So let me quickly introduce myself. My name is Jack. I am a staff product manager here. I work on our platform team, and one of the areas of focus for me is Semgrep Assistant, which is our suite of AI capabilities. And I'm joined today by Drew Dennison, who is a co-founder and CTO. His main focus over the last year has actually been on AI and how AI is going to transform our products and AppSec in general. So we're super lucky to hear from Drew today. And yeah, we're here to talk about kind of the technological frontier that's opening up with AI and LLMs and traditional static analysis. So to put the bottom line up front, we have built an AI-powered AppSec engineer, and our security researchers agree with the decisions that our AppSec engineer makes on triage 96% of the time. So we're going to talk about how we achieve that, how we measure that, what that actually means. And then we're also going to spend a lot of time today talking about how that influences our product and how that's actually driving impact for our customers today. And we're going to do it in kind of three sections. So first, we're going to have a quick introduction to the problem, which is what are some of the challenges that teams face today with the idea of shifting left? Then we're going to turn it over to Drew, our CTO, and he's going to go into depth on kind of the exciting technological frontier and the promise of combining static analysis with LLMs and how you can actually boost the signal to noise ratio quite a bit with those two combined technologies. And then lastly, we'll go into the product side. So again, the practical, how are we actually improving the experience for our customers and saving AppSec and developer time by reducing kind of the noise that our customers might see with traditional code scanning. So let's dive in. So what are some of the challenges with shift left today? I think everyone on the call would probably agree with this statement, which is, in theory, having developers fix things earlier in the development process is faster, it's cheaper, it's better. And I don't think there's any controversy there. But unfortunately, I think a picture is worth 1,000 words. And this is kind of what it has turned into in a lot of cases, right? So it's actually kind of shifting, not just left, but shifting the burden and basically pointing that fire hose of noisy findings, not at AppSec, but at developers. And this is causing a lot of friction, I think, between security teams and engineers at the end of the day. And it's kind of made shift left something that, again, feels good in theory, but is hard to actually put into practice. And if we had to diagnose what the problem is, I think it's really quite simple. It's actually pretty easy to surface issues to developers. You can just build some simple tooling and start to point developers at the findings. The hard part is getting developers to trust those findings and therefore fix them. And at Semgrep, we talk a lot about secure guardrails. And for us, these two things together are what form the essence of secure guardrails. So surfacing things early, but also making it easy to get things fixed. And what makes it hard to get things fixed? So our CEO, Isaac, has a really compelling, I think, AppSec value formula. And it's kind of simple, but I think it illustrates a really important point. And there's kind of three parts of the equation. The first is the finding signal to noise ratio, which is, when we find things, how many of them are real exploitable issues that we want to fix versus, technically correct, but they're not actually that important to fix. The second term in the equation is the prioritized remediation rate. So how often are we actually fixing the things that we do find? And then lastly, what percentage of the things that we fix are as shifted left as they could be, which basically means where is it being fixed? Is it being fixed after a 4-hour Jira ticket gets written up by the AppSec team? That's not as good as if it's fixed in PRs, and it would be even better if it was fixed in the IDE. And what's painful about this equation is each of the terms is kind of scored on a 0 to 1 scale. And what that means is that no component can make up for the other parts of the equation. So even if we had 100% remediation and we were 100% shifted left and we scored 1 on both of those, if the signal to noise ratio is really low, like 0 or 10%, it's going to kind of cancel out all the good work that we did on the other parts of the equation. So you kind of need all of these to be in place to be successful in an AppSec program. And so when we were thinking about, challenges with shift left, we've spent a lot of time thinking about that first term in the equation. And today's presentation is going to go into a lot of detail on this. But it's how do we boost that signal to noise ratio? And again, we kind of define that as it's not only technically correct from the static analysis engine, but it's also correct in context. We don't want to surface things that, again, are technically right. Like, yeah, that's really an SSRF vulnerability, but maybe there's some mitigating part in the code that makes it not exploitable. We don't want to show developers that stuff. And the importance here is that there are just real human cognitive biases that will basically have developers tune out if the signal to noise ratio is too low. There's a lot of studies and research that's gone into this, but if you notify people about things that aren't actually important enough, they will just start to tune out, and they will stop fixing even the important things. So that is kind of the framework that we have been thinking about when we've been kind of building out our AI AppSec engineer. And again, the question is, can LLMs help reduce the noise? And so I'm going to turn it over to Drew, our CTO and co-founder, and he's going to talk a bit more about the technology that went behind this launch that we did last week. Drew, I'll turn it over to you.
Great. Thanks so much, Jack. And hello, everyone. If you have questions for Jack or me, please feel free to put them in the chat. We're excited to answer them, and I'll take questions kind of after the next few slides. So let's start with the signal to noise ratio problem that Jack talked about and how we typically thought about this as an industry. Well, static analysis is the tool we use to find bugs in code, and it's been around for about 20 years. It's really fast, it's really cheap, you can run it everywhere, and you can do some work around customizing the rules, but it also doesn't understand the business context. And so in practice, it leads to a lot of false positives. Let me show you an actual example from our own code base, rule we wrote. If you go to the next slide, this is a basic Semgrep rule that looks for times where you're calling the logger exception function outside of a try except handler. So basically, the way you can think about this is it's going to throw an error because there's a bug in the code. It's not a security issue, but it will cause your application to crash. And it's almost impossible to understand, if you're just writing the rule, all the different ways this could appear. The rule is very simple and basic, but in reality, when you actually write full business applications, you have middleware and other things that will guarantee that there's an exception. And so this would just be a bunch of noise that the team would have to go through and triage, and it would annoy developers who are like, no, this is actually a bug. But it's kind of also unrealistic to expect that the rule author would understand all the context. So next slide. Maybe we can layer in an LLM. And here's where we get an opportunity to understand both the intention of the rule author, right? You're looking for a bug, you're looking for a security vulnerability, but also the code, right? And then what's going to be the impact of this code? Is it running in production? Is it just some test code? Is it internal tools? What's going on there, right? And then as you think about how you want to customize or give feedback to this whole static analysis system, you don't have to learn the arcane underlying compiler techniques that is happening. You get to interact with simple instructions just the way you would with another member of your team. And so that's why we want to use LLMs. You might ask the logical question, should we only use LLMs? And I think the reason right now with state-of-the-art LLMs is it's not deterministic. You really can't audit the findings. It's really hard to collaborate with. So the LLM might be 90% correct, but if you as a human don't understand what's going on under the hood, it's going to be really hard to give feedback. You just get a output, this is vulnerable, this is not vulnerable. And so at least today, with almost state-of-the-art reasoning models, it's too expensive, it's too slow, it's hard to collaborate. And so I don't think we are in a position where we're going to have LLMs fully replacing traditional static analysis. But what we can have is that the best of both worlds, static analysis and LLMs combined, will give us the most accurate results, the best signal to noise ratio. So this is the approach we've taken with Semgrep Assistant. If you go to the next slide. First, we start with our Semgrep Pro engine, and this is the world-class static analysis engine that we do. It gives us very fast, very deterministic answers. And then we use our triage LLMs that we're going to be talking about in depth today to actually filter out only the highest signal true positives that we want to focus on. Then we'll do a whole nother layer of prioritization to understand, okay, which ones are actually exploitable, which ones are connected to the internet, which ones are running with sensitive data, and just reduce the set to the most important findings for your team to actually look at. Then we want to go to every single finding that's important and make sure we suggest a fix, or at least a reason of how you're going to fix this, so that your team doesn't have to start from scratch understand what's going on. Next slide. Okay, so what's actually going on under the hood at the technology level? There's a lot of different components that we've built out over the last year. And just to give you an example for like our code fix part of the component, we actually do some really cool technology here where when we find a security finding with Semgrep and then we use an LLM to propose a code fix, we'll actually rerun Semgrep to make sure that our fix actually passes and the security vulnerability doesn't exist. So we can talk more about that all later, but today I just want to focus on one tiny component of the assistant program, which is our triage chain. So if you go to the next slide, what we realized is that context is the part that LLMs are really, really good at. And so there's sort of three kinds of ways we can push context into the LLM. And that's through pushing a bunch of data into the prompt itself. And so we, as an example, we'll bring in all the matched code, the rule itself, the messages, how confident the engine is that this is an actual vulnerability, any information about the file. We also use a RAG, which is basically a database where the LLM can go and look up information it needs dynamically. And so the context that we're including for the LLM is all the examples of vulnerable and not vulnerable code or any kind of learnings that our team of security researchers have built up in-house. Then we're bringing in a lot of context from the compiler itself. And so this is where you're giving the LLM access to all the data flow, all the type information, all the taint tracking, like anything you can basically use at the semantic level from a compiler. That's the kind of data we want to give to the LLM so it can make the best possible decision. And finally, let's look across the entire ecosystem. So if there's a new finding that is all of a sudden everyone's starting to fix, like when log4j happens or heartbleed or something like this, we want to say, oh, wait a minute, something's going on. You also probably want to look at that. And so we're feeding all this kind of data in to the system. But we want to go even one step further and personalize this to your ecosystem. And so you can customize the prompt, you can scope it out to the specific project, the specific security rule, and maybe any decisions that your organization has made. Like Jack mentioned, if you have a mitigating technology that you're like, okay, we don't care about these kinds of things in our organization, like we should tell the LLM that. And then there's just a couple other things you can include as well. So the kinds of information that we're thinking about here is how do you look at the whole triage history? So if we see that, oh, in the past you fixed a bug like this 5 times previously, like it probably means your organization cares about it and you've invested the effort to go through and fix that. Similarly, we can look at the author and figure out, is this what's the intended change here, right? Maybe Jack's a really great developer and he's always debugging things and kind of doing very nuanced work, but he knows what he's doing, he's very experienced. We probably don't want to spend time looking at his code versus maybe myself. I'm a completely brand new developer. I'm still learning the code base. I'm new to the company. Like as a security team, you can spend more time there. So this is a kind of information that we're pushing in and giving to the LLM that ultimately is going to understand, like, is this a high confidence, important finding that you should look at? Of course, all of this is tied back with the developers. We really believe that developers are the judge of if this is important or not. If you're going to shift left, like Jack said, we can't just give developers that fire hose. And so we take a whole bunch of work from the community, from ourselves, into the assistant to make sure the quality is high. But ultimately, it really depends on, do developers actually fix it? And if they do, great, we want to know that so we can prioritize it. If they don't, let's understand why so we can improve the system. Next slide. Of course, all of this is maximally private by design. We don't want to be shipping your code off to the various LLM providers unless we actually getting value out of it. We have a whole white paper that goes into depth here. But the main thing you really should know is you can bring your own API key. You can choose the company. And we even have the ability to make sure we don't retain or log anything. So would love to chat more if you have specific concerns there. Okay, so as Jack mentioned, our whole goal at the start of the year was, can we use LLMs plus static analysis to build an AppSec engineer that is close enough to humans that you can actually start to trust that the decisions it's making is not just garbage, right? Nobody wants an LLM that's hallucinating a bunch of stuff and creating more work for you. So next slide. And to me, this all starts with trust. So we said, okay, our bar for shipping anything has to be that 90% of the time users look at it and say, I agree with this. And, we feel like that's the sweet spot. 100% would be impossible to get to, but 90% means that you're able to spend time reviewing it, and occasionally you'll get it wrong. The LLM will get it wrong, and you're going to give feedback, but most of the time you agree with it. So we started out by having our security research go through and triage thousands of findings, giving very specific feedback why the LLM was correct or incorrect in early versions. And that was really great to kind of iterate on the prompt and the context we're including and kind of the system architecture. Then we built a couple different evaluation scores. Ideally, we'd score 100% on both. We're extremely happy that on our true positive eval, we're at 96%, which means that when Assistant says that something is a false positive, you can be confident that it's not missing that true positive. And then we're still working on the false positive eval score. It's pretty good. And we think as some of the new reasoning models come out, we expect this number to continue to go up. Speaking of models, this world has changed so much in the last 18 months. I mean, even DeepSeek just came out. We're not using that one yet, although we're going to evaluate it when it rolls out on AWS. But, we've experimented with the latest models from OpenAI, from Anthropic, and we're always picking the ones that, do really well, but are also performant enough and cost effective. So for example, O1, we're not using except in some limited cases because it's actually just too slow to run in the whole PR comment flow, at least with the complexity of the work we're doing. And it's also just a little too expensive to run on full bulk analysis. But we know the cost of LLMs are coming down. And even next week, I expect we'll see some new models from the foundation companies. So when those drop, we can kind of swap those out, rerun all of our evals, and always bring the latest and greatest to the Semgrep Assistant product.
We have two questions in the chat, Drew. Can I fire them at you?
Absolutely.
Okay, so the first question is, have you seen LLMs help at all with SAST false negatives? Or are we just using them for triaging issues into false positives and propose fixes on those true positives? Do you want to give a kind of take there?
Yeah, we have. We've been, again, focused on, I think most companies have way too many findings. And so we'd rather help people figure out, okay, let's get the important ones, and then we'll go through and actually fix those and help the company shift left. But one thing we are doing for false negatives is, can we use LLMs to write more rules and get better coverage of new languages, new language features, new frameworks? And we're seeing great results already, specifically on our supply chain product. But stay tuned for more.
Cool. And then another question that you covered briefly, but someone asked, how is my code protected from unauthorized disclosure? Can you talk about sort of the privacy considerations that we've built into the product?
Yeah, absolutely. So most of your code stays very private. It either runs in your environment and Semgrep runs in agent mode, or it runs in our private cloud. But the vast majority of your code never leaves, that environment. We do send a little bit of context, a few lines above and below the findings, and all of kind of the compiler information that is abstracted away all the code. And then that goes to one of a few providers. So we have great data, enterprise level, data protection agreements with OpenAI, and you can also run things in, bring in your own key, so you can fully control the legal agreements with the LLM providers. We also offer models that run inside of our cloud environment, so the data never leaves our cloud and is not being used to be trained on by a third party.
Awesome. Cool. All right, we'll have a Q&A at the end, so there's definitely questions flowing in, so keep those coming, and we will review them towards the end. Can I take it from here, Drew?
Sounds great.
All right. So as Drew reviewed, we are super excited about the technology that's powering this. I think one of the first questions we had as engineers and as a product team was, okay, is 96% good enough? I think one of the questions that already was asked kind of implied this. And ultimately, our take was, yes, we think it is. And there's a few reasons behind that. One is, just as I talked about in the very beginning with that AppSec value equation, the importance of reducing noise for developers might actually be worth a few false negatives. And the reason for that is to get things fixed, you have to have a high signal to noise ratio. If we're putting a lot of likely false positives in front of developers, they're just so likely to ignore them. And so it's better to miss a couple of true positives. And in this case, it's very few, right? So for every 100 findings, we're only missing like 4 true positives. That's a pretty impressive rate. And our other part of our philosophy here is AI triage is better than no triage at all. If there's something that I hear again and again when I'm speaking to our customers and our users, it's that we're a small AppSec team. I hear that from even our largest customers at the Fortune 500. Every AppSec team is supporting hundreds or thousands of developers, and so it's really hard to imagine actually triaging every single issue in your backlog. LLMs do require a lot of energy, but they don't sleep, and so you can basically start to actually provide a layer of triage on all of your findings, which is something that would be very hard to do without this technology. Relatedly, the thing we hear again and again from our customers is triage is one of the most cognitively demanding things you can do. Imagine you are an AppSec engineer, you are supporting thousands of projects with different languages, different frameworks, and you're switching back and forth, and you have to know so many different things. LLMs have expertise in all those different languages and frameworks, and they don't have that exhaustion that comes from switching context all the time. And so you can actually get a much better sense of what's actually going on in your security backlog if you use LLMs in this way. And then as we segue into the next part of the presentation, which is all about the product changes that have happened due to this technology, we have designed this so that AppSec is still going to review these issues. So you'll be able to come in and see them. We don't close them on your behalf. We're just filtering them out from developers. So we're not notifying them about false positives, but it's still early days, and AppSec still has the final decision about whether something should actually be ignored. So let's segue into how the product has changed. Now that we have this very accurate AppSec engineer that can do triage, what does that actually mean for our customers and for our product? And so at the philosophical level, our vision for Assistant has always been self-driving AppSec or AppSec on autopilot. Now, that doesn't mean we're replacing AppSec engineers. It just means that the tedious, cognitively demanding things that you spend a lot of time on doing that can be done by AI should be done by AI, and we remove humans in the loop where possible. And that frees up the AppSec experts to do the things that only humans can still do. Architectural changes, making organizational changes, things that make your platforms more secure, that only humans can do. And I won't go through all of this in great detail, but again, as Drew mentioned, for us, it's a combination of AI and static analysis. So at the top, you see this box, which is Semgrep Pro Engine, deterministic, traditional SAST at the core of what we're doing. And then AI kind of filters in everywhere along the way. So taking the real deterministic findings from Semgrep Engine, using AI to evaluate if something is a real threat, is it safe to ignore, helping prioritize, hey, understanding where in your code base is this finding, is it in a critical service, is it in a developer script folder or directory, then writing the fix for you, and then helping identify who should fix it, which we hear again and again is a big problem. And then to kind of make it a loop of continuous improvement, how do we refine the policies to get better? How do we eventually help you write more rules so that the deterministic engine gets better over time? And this just becomes a cycle of continuous improvement. So in 2024, all of our AI features, I would say, were all about humans making decisions and then AI providing context to help the human make better decisions. And that was a really exciting and impactful phase for Semgrep Assistant. With AI noise filtering, which we launched last week, we're moving into a new phase, which is AI decisions with human review. And so the first part of the feature in the launch I'm going to go through today is this idea of noise filtering. So we're taking that AI AppSec engineer that Drew discussed, that security researchers agree with 96% of the time, and we're now letting you, as a setting in the product, say, don't interrupt my developers in their workflows and PR comments if Assistant thinks something is a false positive. And so this is a very simple setting that you can turn on here. And you can see in the reporting part of the product, there's this new filtered by Assistant section. So each week you can see how many things Assistant has filtered out on behalf of your developers. Again, this helps increase developer trust and developer velocity because we're only showing them things that are potentially important to fix. And by our conservative projections, we're going to save tens of thousands of hours for our AppSec teams this coming year. Even if you just imagine it takes 5 minutes to triage a finding, the volume that our customers see in terms of the number of the finding is pretty high. And as I mentioned, though, we still think it's human review in this workflow. So trust but verify is our position at this point. Eventually, it will become self-driving, but we're not there yet. So security engineers can still audit this in the product. What they will see is a verdict from AI and some reasoning, like you can see here, where it explains why something is likely a false positive, and the human ultimately decides whether to agree or disagree with that. We're not changing the status of issues. We're not closing things on your behalf. So you're not going to miss any potential true positives, but hopefully we are making the triage process a lot easier. And if you do disagree, you'll be able to add a memory, which we're going to demo for you in just a minute. And again, we are seeing 92%, I think is the latest I've seen in terms of like the agree rate from our actual customers. So not only is our eval set very positive, but we're, in real human examples here, we're seeing very positive feedback from users. So again, as Drew mentioned, the goal is best of both worlds, deterministic engine finding lots of things, AI saying what's a true positive, figuring out what's important. But at the end of the day, and we're not going to spend a ton of time on this in today's presentation, but I wanted to just touch on it, it's all about getting things fixed. And so our promise to developers, or with Semgrep, we want you to be able to make this promise to your developers, is if we interrupt you, we're going to have a fix written for you. And so part of noise filtering is in the PR comments, we have tailored remediation guidance for every true positive that we think developers should fix. So there's two components there. The first is an actual code snippet. So we will actually write the fix and the developer can click a single button to fix it. As Drew mentioned, we actually run that back through Semgrep to determine if it actually fixes the issue. So we're very confident in these things that we put forth for developers. And it also relies on historical fixes, right? So if you fix something similar in a certain way, Assistant will take that into account when it's proposing its fix. We will also write step-by-step remediation instructions. Now, this is great for junior developers or just creating security champions who understand, hey, what's going on with the issue that we're identifying and what the fix is. It's also great because sometimes, a fix requires a config change or changing a file setting or something like that. So those are listed in the steps as well. We're finding that this is helping fix things much faster. So on average, saving about 30 minutes per fix. Which is awesome. It gets better over time, of course. So as I mentioned, it learns from your historical fixes. You can also customize the guidance with natural language or with updates to rules. So with memories, you can actually say, hey, we want to use this framework or this library or this approach to fixing issues like this. And you can also do that in the rule directly. So again, to wrap up on noise filtering, the two promises that we want you to be able to tell your developers are as follows. First, we're only going to ask you to fix real things. We're not going to interrupt you in your day-to-day work unless something is actually a real issue, and LLMs are helping with that. The second thing we are going to allow you to tell your developers is, hey, we're not going to interrupt you if we don't already have a fix prepared for you. And AI is doing a lot to help our customers with that today. Okay. So the second part of the launch last week is this idea, which we're calling Semgrep Assistant Memories. Our CEO, Isaac, wrote a great blog post on this and why he thinks it's the future of SAST. So I'm going to do a quick demo of this, but let me kind of set the stage with the problem. So as Drew has mentioned, we built this triage tool, and one of our customers came to us with a finding like this. It's been anonymized. And they came to us and they said, hey, look, Semgrep, identified this as a SSRF vulnerability, and it's technically correct. And if you look at the remediation advice from Semgrep, it's also correct, which is that we want to perform strict validation on the input here before building this HTTP request. So far, so good. And then they pointed at line 12 in the code and they said, except we are already doing that. The developer is using this sanitizer function to validate the input. And when they came to us and says, like, how can we tell Assistant about things like this so that it gets better over time? So we collaborated with them and a couple of other customers, and we built Semgrep Assistant Memories. So I'm going to move out of slide mode, and I'm going to do a very quick and simple demo, but I hope it illustrates kind of the power of this feature. So I am in Semgrep and I'm logged in and I have a SQL injection vulnerability for the rule of this AIO SQLite Django vulnerability. I wrote 5 kind of identical Python files with just a few differences between them. And let's imagine, I am an AppSec engineer. I'm starting my on-call rotation. I'm doing some triage. I see I have a high severity finding. It's a SQL injection potentially. Assistant has already evaluated this and it thinks it's a real issue, but I'm new to Semgrep, so I'm going to go in, I'll do some triage. And very similar to that example that the customer brought, first thing I notice when I'm triaging this is the user is validating the input here. And so this is probably something that we can call as safe to ignore or false positive. So I can do that and I can just close this one issue. But memories allows me to do something even more powerful. So let's open up the memory panel here. So I'm going to say something just in 1 or 2 sentences of why this is a false positive. So I might say the dev is something like that. So hey, look for similar functions like clean, safe, sanitize. Look to see if they're validating input, and if so, it's likely a false positive. Pretty simple to do, and something, again, I can do. It's just part of my routine triage. I don't need to go learn rule syntax or change a rule. I can just write it very simply like this. I then get to choose the scope for the memory. So I can choose all projects or all just a single project, and I can choose just this rule or all rules. Now, what's cool about this is the memory is going to apply forward-looking. So every time we find similar findings that are scoped in the same way, the memory is going to help improve the triage decision that Semgrep is going to do. But it's also retroactive. So as I change the scope, you can see that the number of findings that we're going to go back and reanalyze increases. So for the sake of this demo, I'm just going to do the same project and the same rule. And you'll see it's going to go back and reanalyze 4 findings and apply this memory to those findings. So I'm going to go ahead and click Add Memory. The memory is now saved. Any finding that is on that rule and on that project going forward is going to have that memory applied. So as it connects to noise filtering, in the future, if there's a similar issue, the developer will not be interrupted in their workflow if they see this. And again, as I mentioned, it's going to go back through in just a minute here, and it's going to go ahead and reanalyze those 4 findings. So if we give it maybe 30, 40 more seconds, we should get notified when that is complete, and we can go see how it impacted our backlog. There it is. So analysis complete. It analyzed those 4 findings, and it looks like 3 of the 4 have been marked as safe to ignore. So let's go ahead and click Review the Findings. And you can see Semgrep has actually analyzed each of these, and it has said it thinks these are false positive. And one thing that I like about it is, each of these is slightly different and has slightly differently named sanitizer functions. And again, you can write rules to look for sanitizer functions. That's totally possible. But it's hard to capture everything, again, thousands of projects, thousands of ways of doing things with a rule. And so with an LLM, just a couple of instructions allowed it to find functions that were named differently, but basically doing the same thing. And so as an AppSec engineer, I could take these 3 and I could just go ahead and I could bulk triage these. And now with memories, I am starting to pay down my backlog and clean things up so that I can only focus on the real issues that I ought to fix. So that is Semgrep Assistant memories very quickly. Let me go through a couple of other aspects here, and I'll give some examples in the real world with our beta customers. So again, as I mentioned, what we like about this is it's able to find similarly named functions that are performing the same task. And again, you don't have to do a lot of complex syntax or rule writing to get that result. Secondarily, this applies to all future findings. So in the future, we're going to filter more findings for your developers, and then we're going to reanalyze them in the backlog. So let's go into a couple examples from our beta and how this is actually impacting our customers. So I've got 3 examples here that I want to go through as a group. So the first one is a rule that is pertaining to secrets, and this is from one of our sales engineers worked with our customer on this one. And basically, they had a framework that was providing secure encryption for their secrets. And so they wrote a simple memory that just said, hey, here's the name of the framework. Look to see if this framework is being used. And if so, it's likely a false positive. And what you can see here was, Semgrep Assistant, the first pass was it found 32 things that could be safely ignored. With this simple memory, and think about it took like a minute to add that, there's 50 more findings that it found in the backlog that were able to be closed because they were likely a false positive. Another example was a rule around cookies. And in this case, the customer wrote a memory that was just kind of like their own philosophy around cookies and how they want to handle it. Again, very similar results, more than 2x the safe to ignore rate that they had over the out-of-the-box assistant rate. And then this is the really exciting one. On the SSRF vulnerability class, they wrote 2 memories. One was just telling Assistant about an internal service that is trusted, and the other one was just giving a little more detail about how they want to think about SSRF vulnerabilities at their organization. And they were able to actually almost eliminate half of the vulnerabilities in their backlog for those rules with just these 2 memories. So again, it's just the beginning, but if you think about, the amount of time that you put into writing these memories, it's pretty minimal for the outcome and the impact that you can see in terms of noise reduction and getting through your backlog and making your developers ultimately happier. I won't go through all of these. We have a bunch of other examples of memories that are being written by our users. These are anonymized, but examples of the kind of things that people are writing today. And then just to kind of close the memory section, we have over 1,000 organizations that are using Assistant today out of the box without any memories at all. Semgrep Assistant marks about 20%, a little more than 20% of findings as potentially safe to ignore. So out of the gate, just by turning this on, you're able to see a pretty significant reduction in your backlog and in the noise that developers are going to see in their workflows. And again, we're super proud about the north of 95% agreement rate with our security researchers. So it's almost like having the Semgrep security research team doing triage for you, but using an LLM to do that. To give you a little bit of kind of thinking about where we're going with this, the future is more scopes. So right now it's by rule and by project, but we want to maybe have it applied to whole vuln classes. And there's a lot of different ideas we have here. So we're very excited about kind of the future of Semgrep Assistant memories. So I want to close with just like 3 points, and then we'll go into Q&A. I see there's a lot of questions coming into the chat, so we will turn it over there in just a second. The first, again, just to sum up, is we're really excited about the future of AI-powered triage, and we are excited that Semgrep Assistant agrees with our security researchers 96% of the time. This is leading to major backlog reduction, and it gets even better when you can add these memories. And ultimately, less noise means more developer trust, which means more fixes, which leads to better security outcomes. And our mission is to profoundly improve the security and reliability of software as a company. And so we are very bullish on how AI is going to help our customers do that more effectively. So I think that's it for slides today. We have some questions coming in the chat. Drew or Chushi, do you want to start to kind of list out some of the questions here?
Yeah, I'm happy to. So we have some questions in the chat and then some just coming through the questions interface. So bear with me. A lot of these questions may require you to go back on some of these slides as well.
Yeah, let me answer one question here about, is it possible to do custom auto triage based off DAS or pen tests? Yes, this is basically aligned with our philosophy that we want to give as much context as possible to the LLM. And so we're working on, kind of integrations with some of these other tools, but also you can kind of give us that organizational context. We've had some folks even give us like PDFs of, wiki pages and whatnot. And the great thing is that that kind of human natural language is really well impedance matched to LLMs, and so you just give that in as part of the context about how we think about things at specific organization, and the LLM can kind of quote that, pulling it out of the database.
Nice, thank you, Drew. This is more product-oriented question for Jack. I guess David's wondering how we evaluate the auto fix, whether from like a user-centric perspective or like, do we have any internal benchmarking for it? What's our methodology there?
Yeah, and Drew can speak to that too. But for autofix, we have two kind of ways we collect feedback. One from our actual users. You can in the PR comment, you can give a thumbs up or thumbs down if you found the guidance to be helpful. So that's one place we look. The other thing we look at is MTTR, and so are people fixing things faster when Assistant posts a comment? As I mentioned, we are seeing a pretty significant improvement in MTTR with Semgrep Assistant fixes turned on. And then we also do a similar process to what Drew described for auto triage, where we have our own internal kind of security researchers create an eval set, and we test to see whether they think it's actually valuable. I think my latest metric on that is more than 80% of the time, our software engineers and security researchers that review these things find it to be helpful guidance. So we have a mix of internal and external metrics to track that, and we'll always continue to try to drive that number up in the future.
Yeah, and I think some future ways we could evaluate it is looking at sort of the edit distance of some of these fixes. I thought there was even a question in chat, right? So if a developer accepts it, but then quickly has to go and fix something because the test failed or something, we would use that as signal that like, okay, maybe this wasn't fully complete fix.
Cool. There's a couple questions here just about the auto fixes and if they are framework or language specific. So I guess, Drew, there's probably a question for you in terms of like LLMs and their just general understanding of languages and frameworks, but then on the deterministic Semgrep side, what are the constraints, obviously, in terms of just like what our engine can do for specific languages and frameworks?
Sure. Yeah. So on the Semgrep engine side, we support a huge variety of languages. I think we have like 31 languages that we support, and it's relatively easy to add in new languages. So that's great on the deterministic side. On actually suggesting the fix or kind of understanding the specifics of esoteric languages and frameworks. The good news is LLMs have read the entire internet and all programming books and all language specifications and everything there. And so you can even go through and be like, hey, suggest the fixes in our language, and it does really well. We've even played around with suggesting fixes in non-English languages, which is just kind of a weird side effect of LLMs being really good at natural language.
Cool. David has another question just around, could Assistant in the future potentially confirm or validate some issues by triggering some sort of like real testing? So I'm imagining just like almost using Semgrep as like a tool at that point to validate certain fixes and whatnot. This is, maybe roadmap oriented. So maybe Jack, you can answer, maybe Drew, you can answer as well.
Drew, you want to take that one?
Yeah. So, I think my thought is that we should not be trying to recreate your entire software development process. We should be working just like any other developer on the team, and we should open, a couple pull requests or things that would actually help fix some code. I think one problem tools have had historically is they'll open hundreds and hundreds of PRs, and your developers are like, what is all this spam? Like, no, we should behave like a well-behaved software engineer and be like, hey, I got 2 or 3 things I'm working on, and then of course pass all your unit tests, pass all your integration tests, just like you would any other piece of the code. So I think that's a scalable approach where we don't have to go and try to recreate builds and test information, but we can just operate like another engineer.
Cool. Good question from Dimitri. So I think with a lot of the hype around some of these local models that are able to actually do a lot, I guess question for you, Drew, is like, do you think we're getting close to a point where maybe like a smaller model that you could run locally could actually like power Assistant to a high degree of accuracy, that we'd be happy like in terms of the performance? And then would it be possible in the future that we have this inference like run on the customer's, I guess, infrastructure?
Yeah, we've seen some really promising results out of Llama. We've done some benchmarking there. DeepSeek, of course, is all the rage right now. A lot of these new reasoning models, like I feel like as an industry, we're learning how to run smaller and cheaper. So I think we'll definitely be seeing this evolve over time. What we have today is you can run in the AWS kind of environment. So it's maybe not like local as it's like running on your laptop, but it's not necessarily having to go all the way out to one of the foundation model providers. Yeah, I think over time this will continue to evolve, and I could definitely see a future where you kind of have an LLM that runs locally in your environment that we just call through like an API proxy or something like that.
Awesome. Scanning for some more questions.
I saw one that I wanted to just, I don't know if everyone can see the questions, but there was a question about, hey, if an org has 10,000 Semgrep findings, what percentage or order of magnitude? Hopefully that's been answered, but we have done this over hundreds of thousands of findings, and it's about 20%. So if you have 10,000 findings, about 2,000 are likely to be marked as safe to ignore by Assistant using this method.
Yeah, and Raphael, I think we had the latest question in chat around feeding memories back into rules and updating the deterministic rules. That kind of goes back, Jack, to your like whole circle of like once you spend a minute and you triage and say, hey, URLs, sanitize functions that are safe or clean or whatever is fast, then you want to basically have another LLM that goes through and says, hey, let me just propose rule fixes that your team could actually review and accept. And so we're doing that right now kind of manually, where we're having our human research team look through the memories that people are submitting and saying, oh, would this be a good rule update or not? But over time, I can see that becoming agentic as well.
Nice. There's been a couple questions about this, Drew. Let me put it to you. So I think if I can summarize them, in my example, we're telling Assistant about a validation step or a function that does sanitization. A couple questions about like, is it smart enough to actually look at the sanitizer function and understand if it's really doing that? What if there's a bug in the sanitization function? Maybe speak to that briefly for the audience, because that's come up quite a few times, I think.
Sure. So what the LLM is getting is the context from the compiler of how the data flows through the program. So we're not directly asking the LLM to prove that this validation function is perfectly correct and doesn't have any bugs, but we are giving it all the context of how the data is flowing inside the program. But yeah, I would just see that this would be an area where the security research teams, or maybe even red teams or pen test teams, would come through and say, okay, we've kind of identified that there's 5 different functions in this program that are doing this critical security work of validating and sanitizing the input. Let's go through and audit those deeply. And so I think that would be a great use of human time, in addition to obviously some of the automated work that we're able to do with both traditional and LLM static analysis.
Okay, let's just scan a little more. Anything else in the chat, Shushi, we should cover? I think we covered a whole class of questions with that answer.
I saw a couple questions about sharing, and you mentioned this at the beginning. This whole webinar is recorded, and will get shared out. So for anyone who wants to go back and look at slides and stuff.